This is a APMT 2003 question from one-dimensional motion. The problem is like this. If a ball is thrown vertically upward with a speed u, the distance covered during the last t seconds of its ascent is how much? That's the question, right? Let's try to visualize what you mean to say. A ball is thrown vertically up with a velocity u. It's obvious that after reaching its maximum height, its velocity becomes 0. For that, it takes a time called time of ascent, right? So, if time of ascent is capital T, be careful, I'm considering it a different T. I can use the formula V equal to U plus CAT. V is 0, U is U, A equal to minus G, and T is the time of ascent. So, time of ascent equal to U by G. So, in a time U by G, it reaches its maximum height. Now, what he's saying is, in the last t seconds, that means in this t seconds, how much is this distance is that it travels you want to calculate, right? So if that is t seconds, as this total time is t, this remaining time becomes capital T minus small t. So before striking that last t seconds here, to acquire a different velocity, I want to calculate what is the different velocity is, right? So what I am going to calculate after t minus t seconds, velocity v dash equal to, of course, the same kind of a formula, u minus g, but after a time of t minus t this time. So you want to calculate only this distance, right? Cover only this distance. That is u minus g capital T minus of minus plus gt. U minus g, t means time of ascent. We already know that value as u by g plus gt. So g and g will cancel. U minus u plus gt. So its velocity v dash is equal to gt. Here it get a velocity v dash equal to gt. So let's consider only this small part x that I want to calculate. So between that small part, if I draw a diagram, if I draw only that part of the diagram, it has acquired a velocity v dash here. It covers a distance x, where its final velocity becomes 0. As it is going against the gravity, acceleration equal to minus g. Now, between these 2 points, between this point and this point, that is this point and this point, we can use an equation v square minus e square equal to 2as. The time is t, yeah, like this. V square is 0, u square is v dash square, a is minus g, s is x. But we already found the value of v dash minus gt whole square equal to 2 minus g into x. So minus g square t square equal to minus 2gx. Minus minus gets cancels. 1g also gets cancelled. So value of the x is gt by 2, right? T square is there. Gt square by 2. So in the last t seconds of ascent, it covers a distance of half gt square. That is the answer for the problem. So to solve this problem, we are using very basic concepts of one-dimensional motion, like time of ascent is u by g. We find velocity just before starting that time, and we know for a vertically thrown body, final velocity equal to 0. Using that basic concepts and equation of motion, we are able to get to the answer. That's how we solve the problem. That's it. Thank you for watching.